everybody find their copy?
Do I gotta check my water?
Go quickly. I think you even might have started yours in class, Josh.
Oh, I think I did too. It's just I don't know where it is. Yeah, I have a copy.
That was just, I think I was writing on that and I left you, that was my scrap paper. Okay, let's start looking at problems on the study guide. If I work a problem, you can fill it in as we go, if you want to. If you want to save it and try it again on your own later, that's fine too. Problems 1 and 2, I'll work one of those. Do you guys have any preference? I'll just do problem number 1. So it tells us we have triangle ABC with C equals 90 degrees in the directions. Okay, lowercase a equals 1. That is side A, so across from angle A. Lowercase b, so side B is 2. We don't know side C. I want to find all 6 trig functions, sine, cosine, and tangent for both A and B. So first thing we have to do is find C. How do I find that third side?
1 square equals C squared.
Mm-hmm. So we get 1 plus 4 equals C squared. Can C be a negative? No. So C is just the square root of 5. Alright, so sine of A. So from angle A, remember SOHCAHTOA, sine is opposite over hypotenuse. Can't leave the radical on the bottom. So we get radical 5 over 5. Cosine of A. So from angle A, cosine is adjacent, so my adjacent side is 2, over hypotenuse, which is radical 5. Get the radical off the bottom. Get 2 radical 5 over 5. Tangent of A. From A, tangent opposite over adjacent is 1/2. Then I asked for sine, cosine, tangent from angle B. So from B, sine opposite over hypotenuse would be 2 over radical 5. Get the radical off the bottom. So that's 2 radical 5 over 5. Cosine of B, adjacent is 1, hypotenuse radical 5. So you get radical 5 over 5. Tangent of B, so from B, opposite is 2, adjacent is 1. So 2 over 1 is 2. Any questions about that? I'm not going to do number 2, it's just like that. Let's talk about number 3. Cofunction theorem. So what are cofunctions? Sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. And they are equal when their angles add up to 90 degrees. So sine of 14 equals cosine of blank. You just have to find 90 minus 14.
Is it different with, like, if it was tangent
It would still be complementary. So, to answer that question, what if I said, use cofunctions to find x, and I said tangent of x plus 10 equals cotangent of 3x minus 5. I said cofunctions, and tangent, cotangent are cofunctions. So what's true about these angles if they're cofunctions? They add up to 90. It's not that the angles themselves are equal, it's that those two things have to add up to 90. So this is kind of two ways I might ask the question. I might give a fill in the blank, or I might set one up and say, okay, what's the variable have to be? So 4x would be 85, and x is just 85 over 4 in that case. So cofunctions aren't necessarily difficult, but you have to remember what's left in them. Alright, is that one okay? The next piece. So this is practicing if you know those function values. So I'm probably not going to work all of them, but I'll do, let's say, 2 of them. So do you have any 2 that you really want me to work out of 4 through 6? Or sorry, 4 through 7? If you had to pick 2?
4 and 7 minus 7.
4 and 7, is that okay with everybody? Alright, so problem 4, sine squared of 45 degrees. So, sine of 45, remember our hand trick? We have 0, 30, 45. Sine is the square root of the top over 2. So that would be the square root of 2 over 2 squared. Plus cosine of 30 is the bottom, or sorry, hold on my 30. It's the bottom, so it would be radical 3 over 2 squared. So if I square this, we get 2 over 4 plus 3 over 4. And that would add up to 5 over 4 for the final answer there. Okay, number 7. 1 over cosecant of 30. Cosecant is the reciprocal of what? Sine. Sine of 30 is radical 1 over 2, or 1/2. So cosecant would be the reciprocal of that. So it's just 1 over 2. So I just evaluate this. Cosecant 30 is plain 30. One thing I'm going to tell you guys, remember that table? Remember this table that we filled out? That will be the first page of your test. Because some people like the hand trick, some people like the table. So I want you to know all those values. That will be the first thing that I ask you to do. If you want a blank one to practice on, I can give you one. I've got a stack of them, so just let me know before you leave today, but that's the first thing on your test.
When we do subtraction values,
Uh-huh.
it's nothing different.
No, same thing. Okay, moving on. I had a few calculator questions. So I went to work 10 and 12, I think. So problem 10. Cotangent of 71 degrees, 20 minutes. So everybody everybody get your calculator. What mode do you have to be in? Degree. So first thing, put it in degree mode. Okay. We do not have a cotangent button. So what do you type in? 1 divided by tangent. And for 71 degrees, 20 minutes, you'll type that in as 71 plus 20 over 60. We should get 0.3378. Okay. Next one is the number 12. Okay. These are the ones that we had to rewrite. Anytime you're looking for an angle, that's when we use those -1 buttons. We don't have a secant button though. So secant is the reciprocal of what? Cosine. So that means cosine is 1 over this. So to find your angle, you will do cosine inverse of 1 over that. I'm probably going to put one on the test like this. You might put a little star next to this one, just making sure you really understand what you're doing on the calculator. So cosine inverse 1 divided by 1.923. And I get 58.664 degrees. What if I asked you to give me that answer in degrees and minutes? Do you guys remember how you get the minutes? Yeah, you take your decimal times 60 and round to the nearest minute. So that comes out to 39.98, so 58 degrees, 40 minutes. So I could ask you to give me your answer either way. Alright, so I'm giving you some pretty big clues about the things on your test. I promise you're going to have one like this. You're going to have that table on your test as well. 13 through 15, we are looking for missing parts of a triangle. Doesn't matter to me. Let's pick one of those. Do you guys have a preference? 13. Okay. We have triangle ABC. C is the right angle. Okay, side A is 68.0. So how many significant digits am I using on my answer? 3. Side B is 104. On the test, I will specify on the problems I want significant digits. I will say answer with significant digits. So I will tell you that. Alright, if I want to find angle A, using the two sides that are given, what could we do? This is the opposite and the adjacent side, so I would do which tangent of A equals the opposite 68 over the adjacent 104. So anytime you want to find an angle, that's when you do the inverse. So second tangent, 68 over 104. If I give 3 significant digits, that would be 33, it's 0.1785, so 33.2 degrees. Once I have that, it's pretty easy to get angle B. What would we do?
You plus that, and then 180 minus whatever the
these angles have to add up to 180. So 180 minus 90 is 90. So if we do 90 minus the 33.2, we get 56.8 degrees for angle B. To find side C, you have two options. We could do Pythagorean theorem. Let's practice a trig function just because that's what you're going to need to do on 14 and 15. If I wanted to find it with the trig function, from here, from A, I could do sine. Sine of angle A, which we found was 33.2 degrees, equals the opposite side, 68, over the hypotenuse, which is C. If I want to get rid of the fraction, you always have to multiply by the denominator. So then to get C by itself, you'll have to divide by the sine. So 68 divided by sine 33.2, and I get that side C is 124. It's like 0.1865, but only 3 significant digits, so I would just say 124. Again, you could have found that with Pythagorean theorem. I just did this to practice using the trig function for you.
When you have the degrees and minutes, do you have to put it like subtracted from the?
You would do, so if I said like 33 degrees 12 minutes, and you typed it in, you'd do 33 plus 12 over 60.
Okay, so you wouldn't change it before you do like the triangle?
No, you just leave it. Other questions there? Okay, let's talk about 16 through 19. I can promise you there will be a section on your test like this, and I'm expecting certain work when you go through these. So these are not going to be 1-point questions. They will be worth probably 2 points each, and I'm expecting you to show me quadrant and reference angle every time. Now 420 is too big, so we'd start out subtracting 360 from that. And if you do 420 minus 360, you just get 60. So I don't really need quadrant or reference angle. If you use your hand trick, fold in 60, tangent is square root of the top over square root of the bottom. So it's radical 3 over radical 1, which just gives us radical 3. So 315, what quadrant is that in? Reference angle. In quadrant 4 you do 360 minus 315, and you get 45. So you'll have 1 point for telling me that quadrant and reference angle. In quadrant 4, is sine positive or negative?
Positive.
All students take calculus. So in quadrant 4, cosine is positive, so that means sine would be negative. And then the sine of 45, so if I use my hand trick, sine is the square root of the top over 2, so I get negative radical 2 over 2. I'm going to let you guys do 18. What would you do if you have a negative angle? Add 360 first. Let's do problem 19 together. So this problem would be worth quite a few points, because I'm expecting you to work out each of these trig functions. So it is a very bad idea to just write down a final answer. 120 is in what quadrant?
3,
2. Reference angle. In quadrant 2, you do 180 minus that angle, and you get 60. In quadrant 2, all students, sine is positive, so tangent would be negative. Tangent tangent of 60 is?
Right over.
Mhm. Plus 3 sine squared of 150. So 150 is in quadrant,
Two.
the reference angle. 180 minus 150 is 30. So sine of 30,
102.
okay, 180 isn't really in a quadrant. And we don't have a hand trick for that, but that's when we went back to this picture that we did in chapter 1. So that point, 180 is right there, our point is negative 1, 0. We know in this picture r is always 1. So cosine is x over r. So negative 1 over 1 is negative 1. So keep in mind the amount of work I am showing you when I work this out. This is what I expect from you. So negative radical 3 squared is just a positive 3. 1/2 squared is 1/4. Negative 1 squared is 1. And I think we get negative 25 over 4. Wait, hold on. That's wrong. That's not a negative 2, is it?
Negative.
That's a positive 2. So, should be 23 over 4 for the final answer.
Wouldn't the 3 still be negative in the 2 parentheses start?
Right here, if you square a negative, take a negative times a negative, it becomes positive.
Okay.
Anything else? Okay. Then we get into all the word problems, which I told you I was putting a lot on here because I figured that was the thing that you needed the most practice with. So far in our test, we know we're going to have a table, we're going to have some, like solve for the missing pieces of the triangle. The next thing we have on here, let's go ahead and look at problem 20. So the altitude of an isosceles triangle. What's an isosceles triangle?
Triangle with 2 sides.
Okay, so I'm going to draw a triangle, 2 congruent sides. What's the altitude?
25 centimeters.
Okay, and the altitude is right here. That would form a right angle, and this is 25. And remember, if it's isosceles, if those two angles or legs are the same, then those angles down there would be the same as well. Okay, so we know the height is 25. And each of the 2 equal angles is 17 degrees. How long are the sides? Use significant digits. So I need to find these. So if we take just this piece, we have a right triangle. And we could set up a trig function. From this angle, that's my opposite and my hypotenuse, so what trig function?
Sine.
So we could say the sine of 17 degrees equals 25 over x. Get the x off the bottom and multiply by x over. Then we would have to
Divide by sine.
okay. So 25 over the sine of 17. but I said use significant digits. So significant digits, how many were given in the problem? So if I round this to 2 significant digits, we would call it A6, and we were in centimeters. Is that one okay? I want to, 21 and 22 are both angles of elevation and depression. I'm going to skip 21 and leave that for you guys. Let's look at problem 22 together. Alright, so 2 guy wires from the top of a 35-foot tent pole are anchored to the ground below by 2 stakes. The tent pole is perpendicular to the ground in between the 2 stakes. So we've got the ground, we have a tent pole that's perpendicular to it, and we have these wires that are anchored to the ground on either side. So this is my picture. The tent pole was 35 feet tall. Alright. If the angle of depression from the top of the pole to each stake, remember if it's an angle of elevation, it starts at the horizontal and goes up. Angle of depression starts at the horizontal and goes down. It says from the top of this pole, so you have to draw in your horizontal. From that going down, my angles, one of them is 47 degrees, the other is 43 degrees. How far apart are the stakes? Alright, what I'm going to have to do here is really, we can't do anything with the whole triangle because it's not right. So we'll have to take the 2 smaller ones. We're trying to find how far apart these things are. So essentially I'm going to have to find x and y and then do what with those? I want to know how far it is from point A to point B. We'll have to add them at the end. Okay, so I'm going to find x, I'm going to find y, and then I'll add those answers together. I need an angle in my triangle. So let's start over here with this. Okay. This angle out here is 43. These 2 together should make a right angle, right? So 90 minus 43 is, so the angle inside the triangle is 47. So from here, x is opposite, 35 is adjacent, so that would be tangent of 47 equals x over 35.
Did you do that for that?
That green triangle, yeah.
So like that would be 90 degrees
Yes.
to,
Yes, because this is a horizontal, so it's still perpendicular to that. So then to solve for x, we can multiply over our 35. So 35 times the tangent of 47 degrees. Okay. Now let's look at the second triangle. So if I'm looking over here, I need an angle inside the triangle. These 2 have to make 90, so 90 minus 47 is 43. So I could say the tangent of 43 degrees equals my opposite, y, over my adjacent, 35. bother what's on the denominator. Then, to find the total distance apart, you just have to add those two answers. I said to answer with significant digits. How many significant digits were given in the problem?
2.
So when you add these, you get 70.1709, so you would call it just 70 feet, since we're using significant digits. Is that okay? Let's do some bearing problems. So 23, it's a good bearing problem. A boat leaves a harbor entrance and travels 25 miles in the direction north 42 degrees east. So we have our starting point. Anytime you measure bearing, what do you have to draw in? Yep, north-south line. Okay, from there, I said we are going north 42 degrees east. Okay, so I'll take you out here. The angle goes from the north-south line. So that was 42 degrees. The captain then turns the boat 90 degrees and travels another 18 miles in the direction south 48 degrees east. Okay, I can also label this side because it said it was 25 miles. We're going to measure bearing again, so we need north-south line where we're at. And this time we're going south 48 degrees east. For another 18 miles. So that side is 18. This is 48. At that time, how far is the boat from the entrance? So I'm looking for this side. Now, there's one other piece that I gave you in this problem. When he turned right here, I said he turned 90 degrees. So this little piece of the angle is 48, but what that means is this whole thing is a right angle, which is great for me because now I can use trig functions. If I want to set this up, I need to have an angle in my triangle, correct? Or if we know it's a right triangle, what could we do to find my missing side? Because I didn't give you any of the angles in the triangle, but you have two sides, you know it's a right triangle, you could get the third. So 25 squared plus 18 squared equals x squared, because x is the hypotenuse. I said to answer with significant digits. Square root, we wouldn't have a negative here. It's got to be a positive. How many significant digits did I give in the problem? 2, so this would be 31 miles. Okay. I'm going to kind of start bouncing around. So we may come back and hit some of these word problems, but I think another bearing problem might be beneficial. So let's try another one. How about 27?
Is there a chart to know which ones are
When it gives you like the looking at the problem, when it says like north 42 degrees east, that tells you it's bearing. So if we look at 27, a boat travels on a course of bearing north 37 degrees 10 minutes west for 79.5 miles. So I've got my starting point. If you want bearing, you need that north-south line. You are going north, west. So this angle right here is 79 degrees 10 minutes. And we're traveling for a distance of 79.5 miles. How many miles north and how many miles west has the boat traveled? Okay, this one isn't too bad because we can just finish off this triangle. If I want to know how far north and west it's traveled, I can just think of this triangle. Trying to clean up my picture a little bit. Huh?
How do you know it's a right triangle?
Because we want just the north and the west. So when you take a north-south and an east-west line, they always form 90 degrees. So we have to find, this would be my north and this would be my west measurement. So to find my north from my angle that's adjacent, I know the hypotenuse, so that would be cosine. 79 degrees 10 minutes equals the north over 79.5. Multiply over the 79.5. And then just putting that in the calculator. Significant digits, I didn't say that on this one, so we don't have to. If I don't specify significant digits, then I expect 3 to 4 decimal places. So 14.9422, and we were in miles on this one. If I want to find my west, what trig function would I use? Sine. So the sine 79 degrees 10 minutes equals west over 79.5. And so my west distance is 78.0832. Okay. We have a few minutes left. Do you have any questions on that one? Is this stuff coming back to you as we're going through it? A little. Let's do 25. My recommendation to you guys, test Monday. I will probably post the answer key to the study guide on Classroom. If you need a blank table to take and practice, do that because that will be the first thing on your test. I would also recommend going back through and maybe covering up the answer or reworking a few of these problems that we've gone through, because I have worked through something like every question on the test. Okay, I've tried to make sure and hit all the highlights for you. So 25, this is probably the last one we get through. A 72.5 foot rope from the top of a circus tent pole is anchored to the ground 43.2 feet from the bottom of the pole. So we have a pole. The rope is going from the top of the pole down to the ground. Okay, the rope was 72.5 feet. The distance on the ground we said was 43.2. And we could assume, it says assume the pole is perpendicular to the ground. What angle does the rope make with the pole? So which angle am I looking for? The one at the bottom or at the top? Top, because it's a rope with the pole. So that's the angle we need. Alright, so from there we have the opposite side and the hypotenuse, so what trig function? Oops, sine of theta equals the opposite, 43.2, over the adjacent, or the hypotenuse, excuse me, 72.5. So anytime you want an angle, we change it to sine inverse. I did not say significant digits, so we get 36.5741 degrees. Any problems that I have skipped and you would like for me to go through? Like I said, I will try to post the answer key to this. I do want it done before the test. I'll collect it, but we've worked through most of it. You might try reworking some of these problems, making sure you remember everything. What if we didn't do very many of these? Let's try just a couple more. If I said cosecant of 330 degrees, what two pieces of information do I want you to write down? What quadrant is 330 in? Reference angle in quadrant 4. You do 360 minus 330. Okay, in quadrant 4, cosecant, when I see cosecant, I'm thinking about sine, because I know they're reciprocal. So if we think about all students take calculus, cosine's positive, so sine would be negative, so cosecant would be a negative. 30 degrees, sine of 30 would be radical 1 over 2, so 1/2. Then how do you get cosecant from that? You flip it. So basically what we know is the sine would be a negative 1/2, so cosecant, if you flip it, is negative 2. So just remember we can get those others by doing those reciprocals. Who would like a blank table?